Welcome back to the deep dive. Today, we are going to, well, we're going to break your brain.
Yeah.
And I'm not saying that lightly. We're going to take the way you visualize the universe, specifically, the way you picture time and space, and we're going to completely shatter it.
It's a big claim.
It's a huge claim.
Yeah.
But, and this is the promise I'm making right at the top, we're going to put it back together in a way that is, I think, much more elegant, much simpler, and weirdly much more human than what you probably learned in physics class.
It is a bold promise.
Yeah.
But looking at the source material we have today, I think it's actually justified. We aren't, looking at a paper from Nature or a lecture from CERN.
No, not at all, and that's the hook.
Yeah.
Really, this is a physics rebellion, but it's coming from this incredibly unlikely place.
Right.
We're diving into a series of documents. They're dense, sometimes they're a little chaotic, but they're also mathematically rigorous. And they document a dialogue between a human author and ChatGPT.
Which, I know, it immediately sounds like a gimmick. I can just picture you listening right now, rolling your eyes.
Oh, yeah. Oh, great. The chatbot solved relativity.
The chatbot solved relativity, exactly.
Yeah.
But when you actually get into the PDFs, and we're talking about files with names like ChatGPT, Dugosianid, and Observation Reconstruction Model Complete, you realize this isn't the AI hallucinating.
Not at all.
It's the human using the AI as a kind of sparring partner.
Yeah.
A tool to build a completely new geometric framework from the ground up.
It's almost like the human is trying to deprogram the AI.
Yeah.
To jailbreak it from standard physics.
That is exactly what is happening. And the theory that comes out of this is called the observation world tube. It challenges this fundamental idea in physics, this God's eye view of the universe that we've all just accepted since Newton and even Einstein.
The God's eye view, I love that phrase. It's the idea that we can just, look at the universe from the outside.
Yep.
Like it's a map laid out on a table.
Precisely. Standard physics just assumes we can draw a grid XYZ in time, and we can just place events on it like we're omniscient. Event A happened here at 2:0 p.m. Event B happened over there at 2:05 p.m.
Right. Instantly.
But this new model says that whole view is a fallacy. It argues we aren't gods looking down at a map. We are users. We are inside the system.
A user interface view of the universe.
Exactly. And if you confuse the user interface with the underlying hardware, you get paradoxes. You get all the weird stuff.
Like time slowing down or objects physically shrinking just because they're moving fast.
Right. The observation world tube suggests those aren't actual physical changes to reality itself. They're rendering artifacts of our interface.
Okay, let me see if I've got this straight. Einstein wasn't wrong. He was just describing the screen, not the computer.
That is the core argument in a nutshell. He was describing the effects of the user interface, not the fundamental workings of the machine.
Okay, so our mission today is to really understand this observation world tube. We're going to unpack these specific documents, the PDFs, the text files. I think there are even some Python scripts for a 3D program.
For Blender, yeah. We need to try and separate the illusion of what we observe from the reality of what actually exists. And I should give a fair warning. This gets geometric. We are going to be visualizing circles and tubes and rotations. It's very visual.
I have my mental protractor ready. But before we get to all that geometry, we have to talk about the spark, the origin story. Because this didn't start with a neat math equation. It started with a blog post draft and basically an argument with a chatbot.
It did. The document is called Draft, Math, Perception, Others, 028 GPT Extra. And it's just fascinating because you can see the author's frustration in real time. This author has an intuition, this nagging doubt about special relativity.
What was the specific beef? Because, usually when people challenge Einstein, they're just cranky commenters on the internet saying relativity is a hoax or something. This feels different.
It's very different. The author isn't denying the results of the experiments. They're questioning the interpretation of those results.
Okay.
The core critique is all about measurement. The author argues that physics, for a century, has confused math on paper with actual operational measurement.
Break that down for me. Math on paper versus measurement.
Okay, let's go back to that omniscient mathematician we mentioned. In a thought experiment, you can just say, let there be two flashes of light, one on Mars and one on Earth, and let them happen at the exact same time.
Right. In my mind, I can see both instantly. I'm God.
You're God. You can visualize the whole solar system in your head, no problem. But in the real world, you are a person standing on Earth. You cannot know the flash on Mars happened until the light from it actually reaches you.
Which takes minutes.
Right. You are stuck in a location. You are limited. You're just waiting for data to arrive. The author argues that standard relativity creates these frames of reference that are treated like little self-contained omniscient bubbles. It sort of ignores the physical reality that to get any information, you have to actively catch it.
Catching the information. This leads us to that analogy from The Source, the one with the rain, right?
Yes.
The Bradley aberration.
Yes.
Yeah.
James Bradley, way back in the 1700s. And this is a piece of crucial physics that often gets glossed over, but it's central to this whole argument. The analogy is so simple.
Lay it on me.
Okay, you're sitting in a car, it's parked, it's raining, and the rain is coming straight down. There's no wind. The raindrops hit the side window vertically.
Easy enough. Vertical streaks on the window.
Now you slam on the gas. You start driving forward at 60 miles an hour. What do the raindrops look like on that side window now?
They streak diagonally. They look like they're coming from in front of me, slanting backwards.
Exactly. Now imagine you have a long hollow tube and you want to catch a single raindrop at the top opening and have it fall all the way to the bottom without hitting the sides.
Yeah.
If the car is moving, you can't hold that tube straight up and down.
No, I'd have to tilt it.
You'd have to tilt it forward, right, to match the angle of the falling rain relative to your own motion.
To intercept the drop.
To intercept it. That tilt is the aberration. Now, just replace the rain with light from a star. The Earth is moving around the sun at about 67,000 miles per hour. We are moving through this rain of starlight.
So to see a star, we have to tilt our telescope.
We have to tilt our telescopes. We can't point them exactly where the star is. We have to point them slightly ahead of its position to catch the light as we move forward to meet it.
That makes perfect physical sense. But the author's claim is that standard relativity just ignores this. That seems unlikely.
The critique is subtle. It's not that they ignore it exists, but they ignore its implication. The author points out that this tilt, this aberration, proves that the observer has an absolute velocity against the external world.
You're moving through the field of light. Your motion is real.
It is objectively real. But then we have the famous Michelson-Morley experiment.
The one that broke physics, the search for the ether.
Exactly, the experiment that failed to find the ether wind. They tried to measure the speed of light in different directions, expecting that the Earth's motion through this supposed ether would change the result, and they found nothing.
Zero difference. The null result.
The null result. And the textbook conclusion from that is, okay, so there is no background. There is no ether. The speed of light is constant for everyone, everywhere, no matter how they move.
Which is the foundation of Einstein's theory.
Right, and that's what leads directly to special relativity. But the author of our source documents looks at that same experiment and says, wait a minute.
What's the objection?
The objection is that Michelson and Morley assumed their apparatus, the big stone table with the mirrors and the light beam, was a static geometric frame. They treated it like a closed box.
Right.
They didn't account for the fact that the light itself is traveling through the universe independently of their machine. The machine is moving to intercept the light.
So they were trying to measure the wind, but they were doing it from inside a sealed room? Is that the analogy?
It's sort of like that. The author argues the null result wasn't proof that space itself is weird. It was a failure to properly account for the information limits of the observer. It was a failure to realize that the apparatus itself is moving through the data stream.
So if you don't account for how you move to catch the light, just like tilting the tube to catch the rain, you're just doing abstract math. You're not doing physics.
You're not doing physics. It has to be an operational definition. Physics should be about the physical act of measuring, not just the abstract concept of existence.
And this is where the AI comes in, because the author tries to explain this idea to ChatGPT.
And ChatGPT does exactly what it's been trained to do. It just recites the textbook. It says, well, according to special relativity, there is no preferred frame of reference, blah, blah, blah.
I can just feel the frustration. It's like shouting, no, listen to me, I'm talking about the rain.
And this is where the jailbreak happens. The source documents, they show the author creating these things called primary prompt sets. They're basically logic traps for the AI.
What do you mean logic traps?
The author gives it a new set of axioms. They say things like, for the rest of this conversation, assume a coordinate system where m is not time. Assume strictly geometric relationships based on the unit circle. They're forcing it to play a game with brand new rules.
They wipe the slate clean.
Yes. They explicitly, and this is a quote, they explicitly prohibited the AI from using the concept of time dilation as a physical explanation. They said, explain this using only the geometry of signal reconstruction delay.
And did it work?
It worked brilliantly. Once the AI was forced to abandon its training weights that were all based on Einstein, it started deriving this new geometry. It became the first entity to mathematically formalize the author's intuition.
That is just wild. We usually think of AI as, a tool to cheat on your homework, not to help you rewrite the textbook.
It points to a really interesting future where AI could help us step outside of our established scientific paradigms. Humans have biases. We have dogma. And AI has training weights, but if you know the right prompt, you can zero them out. You can force it to think from a completely alien perspective.
Okay, so they wiped the slate clean. They zeroed out Einstein in the AI's mind. What did they build in its place? Let's get to it. We've got this observation world tube. Let's build it from the ground up.
We have to start with the coordinate system. Standard physics uses x, y, z for space and t for time, 4 dimensions. This model throws a huge wrench in that. It introduces the m-axis.
The m-axis.
Right.
I was looking at the graphs in the PDF, and it looks like it represents depth, like a z-axis going into the screen. But the text screams, it's in all caps, MIS not time.
Correct. And this is, without a doubt, the hardest conceptual hurdle for people to jump. M is not time. M stands for memory, or sometimes the source calls it memory retrogradation.
Okay, I'm already struggling. If it's memory, isn't memory just the past? And isn't the past time?
It's a different aspect of the past. Think of it this way. Time. The t-axis in this model is the forward flow of causality. It's the clock ticking on your wall. T moves forward for everyone, everywhere. That's the river.
Okay.
M is different. M is the distance into the past. You have to look to see something right now. It's a measure of data latency.
You mean an analogy? I need an analogy.
Okay, imagine you were looking at a super advanced computer screen. The screen is flat. That's your view of the world. Let's call it the x-axis, left or right. Now imagine the depth into the monitor isn't physical depth.
Like in a 3D movie.
More like a database. Imagine that every single pixel on your screen isn't just a glowing light. It's a file being pulled from a massive hard drive. Some files are fresh. They were saved 1 millisecond ago. Some files are really old. They were saved 10 years ago.
Okay, so the stuff close to me on the screen is made of fresh data. The stuff far away is made of old data.
You've got it. In this model, you, the observer, are at the center. You are at seconds of dollars now. You look out at a star that is 10 light years away. So its position is sex and $10. To render that star on your screen right now, at times $t went, your system has to pull a data file from 10 years ago.
Because the light took 10 years to get here.
Right. So for that star, its coordinates, in your view, are sex and $10 and $110. The memory depth you have to reach into is 10 years.
Okay, sex and $10 and $10. I see that.
Now look at the moon. It's about 1 light second away. So its coordinates are sex and dollar pants, son of war.
And if I look at my own hand right in front of my face, it's basically 6 $.
Exactly. Now plot those points on a graph. X is the horizontal axis and M is the vertical axis, representing that depth into memory. You have a point at 0, 0, a point at 11, a point at 10, 10. What shape does that start to make?
It's a straight line at a 45-degree angle.
Yeah.
Or a V shape if you look both left and right. A cone.
In standard physics, yes, that's the famous light cone. But this source material argues that for the observer, the collection of things you can see at one instant doesn't form a cone. It forms a circle.
But circle, why a circle?
This is where the unit circle comes in from the prompts. The fundamental equation of observation in this model is $6 plus M2 equals R22.
That's Pythagoras' theorem. $8 plus B2 equals C22.
It's just the equation for a circle. Here, $3 is a constant called the pseudo-photon lifespan. You can think of it as the maximum rendering distance of your observable universe, the absolute limit of your perception.
Okay, but I'm still stuck on why it's a circle. Why isn't it just a straight line sex a letter? Why the squares?
Because of the conservation of information speed, which is light speed, think of $2 as your total observational budget or your reach. You only have so much reach to spend at any given instant. If you spend a lot of it reaching out far in space on the x-axis, you must spend a corresponding amount reaching back in memory on the m-axis. The collection of all points that you can see at this exact instant forms a semicircle around you.
A semicircle. Okay, let me visualize that. I'm standing at the center. The horizon of my reality isn't a flat line off the distance. It's a curved surface that wraps around me in this abstract XM space.
Correct. The now that you experience isn't a flat slice of the universe, it is a curved interface. Every point on that semicircle represents a piece of light that arrived at your eye right now at 2:05 glance, but each piece came from a different distance and a different time in the past.
So my now is a composite image. It's a mosaic made up of pieces with different timestamps.
Beautifully put. It is a mosaic, and that mosaic is your user interface. You never, ever see the raw database of the universe. You only see this reconstructed mosaic.
Okay, I think I have the semicircle. That's my snapshot of now. But time, the t-axis, is still ticking forward. My clock is moving.
It is. So imagine taking that semicircle, that curved slice of your now, and as time ticks forward by 1 second, you stack another new semicircle right on top of it, and a second later, another, and another.
Like you're stacking pancakes.
Or poker chips.
Or stacking coins, exactly. If you stack a huge number of circles or semicircles on top of each other, what shape do you get?
You get a cylinder, the tube.
The observation world tube.
There it is.
That's the whole structure. The observation world tube is not a physical object floating in space. It's not a wormhole. It is a stack of information layers. It represents the complete history of everything the observer has ever seen, all reconstructed from the light arriving at each consecutive moment. It is a geometric log file of your entire perceptual life. Okay, I'm visualizing this tube. It's like I'm a worm burrowing through time, and my skin at any moment is this mosaic of light from the past. But here's where it has to get tricky. Motion. Because the whole point of relativity, the reason it's so weird, is because of what happens when you move.
This is the absolute pivot point of the whole theory. In standard physics, velocity is linear. You move along the x-axis. The formula is simple. Velocity equals distance over time.
I drive my car down the road. Linear motion, straight line.
But in the world tube model, you have to remember the first rule. You are always at the center of your observation. You are always at last m-allers in your own view.
I'm the center of my own universe. Sounds a bit narcissistic, but I guess it's physically true from a perceptual standpoint.
It is. So if you are always at the center, how do you represent movement? You can't just leave the center of your own view.
The background moves past you.
You're close. The source says that movement is redefined not as linear velocity, but as angular velocity on the semicircle.
Angles, rotations. But I'm driving in a straight line. How is that a rotation?
Think about the train analogy from the source. This is vital to understanding it. You are sitting on a train. The train is moving at 100 miles per hour relative to the ground. But to you, sitting inside that train, the floor is perfectly still. The cup of coffee on your table is not moving.
Right. My local inertial frame is stationary. I feel at rest.
So how do you achieve that feeling of being at rest while you are actually in motion? The source argues that you are effectively rotating your gaze in this XM space. You are rotating your entire coordinate system on that semicircle so that the train floor stays locked at the 90-degree position, the center of your view, while the outside world rotates past you.
It's like a camera pan. If I'm filming a runner and I pan the camera perfectly to match his speed, the runner stays in the center of the frame, sharp and clear. It's the background that blurs and streaks past.
Boom. That is it. That's the core mechanism to create a local inertial frame. To feel like you are sitting still when you are actually moving at high speed, you are performing a continuous geometric rotation on the XM semicircle.
So I'm rotating my view into the M-axis, into the depth of memory.
Yes. You are changing the angle at which you are slicing through the memory space data. And this simple rotation, this purely geometric camera pan, is what causes all the weird, seemingly paradoxical effects of special relativity.
Okay, let's fight about this for a second, because this sounds way too simple. You're telling me that the paradoxes that give PhD students headaches are just camera angles.
Let's test it. Let's take the first big one. Lorentz contraction, length, shrinking.
Right.
Standard physics says, if a spaceship flies past me at 90% the speed of light, it physically gets shorter in the direction of motion. The fabric of space itself squishes it.
Which is, I mean, it's just absurd on its face, but experiments prove it happens.
Yeah.
Particle accelerators literally rely on it to function.
The experiments prove the measurement changes. The perceived length changes. Now let's look at it with the tube model. You have an object, say, a spaceship, and it's represented as an arc on the semicircle. It has a fixed arc length. The spaceship itself doesn't get squished. It stays the exact same size on the curve.
Okay, so the real spaceship in this abstract space is fine.
It's fine, but you, the observer, are looking at it from a rotated angle because of your relative velocity. You are projecting that curved arc onto your flat x-axis, your screen.
Shadows again. We're back to shadows.
It's all about shadows. If you take a pencil and hold it sideways, parallel to a wall, its shadow is long.
Right. It's full length.
Now rotate that pencil so it's pointing away from you, into the depth, into the m-axis, and look at its shadow on the wall.
The shadow was much shorter. It's just a dot if I point it straight at the wall.
Exactly. The shrinkage is just foreshortening. The object has rotated into the memory depth of your observation field because of its velocity relative to you. You are seeing less of its x profile and more of its m profile.
So things don't squish. They just turn away from me.
They rotate into the past.
They rotate into the past. That is a poetic and also a very confusing sentence. But it explains why the math works, doesn't it? The math of rotation is the math of Lorentz contraction. It's all just trigonometry.
Yes. It's all sine and cosine. The source documents explicitly derive the Lorentz factor, that gamma symbol from the textbooks, from simple trigonometric relationships on the circle. There's no magic required. It's just high school geometry.
Okay, what about time dilation? This is the big one, the twin paradox. One twin stays on Earth, the other gets in a super-fast spaceship, flies to a nearby star, and comes back. When they reunite, the traveler is younger.
Standard physics says that time itself literally slowed down for the traveler. Their clock ticked slower, their heart beat slower. Everything ran in slow motion relative to the Earth twin.
And in the world tube model?
The world tube model says, look at the path they took. Not through space, but through this information tube.
The path on the graph.
Right. Remember the equation? Text $$ plus M2 equals R22. You have a limited budget, $3. If you are the traveler, you are rotating your angle on the semicircle constantly. You are changing the mix of space and memory that you traverse.
I'm spending my budget differently than my twin on Earth.
The twin on Earth travels a more or less straight line up the tube. Their path is almost pure time, the t-axis. The twin in the spaceship travels a spiral path, a helix, wrapping around the surface of the tube because they are constantly moving through space and time.
And geometry tells us that a spiral path between 2 points is longer than a straight line. But wait, how does a longer path result in less aging? That seems backward.
This is where it gets really, really interesting and subtle. In this geometry, because of the way the memory axis functions, when you rotate, you're sampling the M layers differently. The source describes this as a display artifact.
A display artifact, like a glitch in a video game.
Kind of. Think of it like a frame rate or a refresh rate. When you move fast, which means you're rotating your view on the semicircle, you are forced to update your now mosaic by grabbing data from deeper and deeper in the m-axis. You are, in a sense, lagging behind the universe's data stream more than the stationary twin is.
So the slowing of time is just me processing the data stream with a higher latency.
That's the interpretation. The traveler isn't aging slower in some mystical biological sense. The information about the traveler is being constructed via a longer, more circuitous path through the memory buffer of the universe.
The twin paradox just becomes a path integral problem.
Exactly.
The traveler took a different geometric route through the information field. So when they meet back up, their personal odometers, their clocks, show different numbers because they've traveled different distances through the M structure of the tube.
It completely demystifies it. It makes it sound less like time travel and more like an odometer discrepancy after taking two different routes to the same destination.
Okay, but I have to push back here. Because if this is just a display artifact, why does the twin actually come back younger? Like physically, his cells have divided fewer times. His hair is less gray. That's physical reality, not just a display issue on a screen.
This is the absolute crux of the user interface theory. The model argues that physical reality as we experience it is the display.
Whoa.
There is no separation. Your cells divide based on the causal flow in your local frame of reference. If your local frame is rotated because of your motion, your entire causal flow is rotated relative to the Earth twin. To you, in your spaceship, your cells divide normally, your clock ticks normally, 1 second is 1 second.
But to the Earth twin looking at my data?
To the Earth twin, your entire system appears to be lagging. When you return, that accumulated lag is realized as a real physical age difference. It's all relative.
It's all strictly geometric. And this must be how it handles simultaneity, too.
Of course.
The whole idea that two events can happen at the same time for me, but not for you if you're moving.
It's the salami analogy. It's perfect for this.
I love the salami analogy.
The observation world tube is like a giant salami made of information stretching through time. If I'm stationary, I slice that salami straight down vertically. That slice is my now, and all the little bits of meat and fat on that slice are simultaneous events for me.
Okay.
But if you are moving relative to me, you're slicing that same salami at an angle, say 45 degrees. You get a completely different cross-section of meat and fat.
Different events are now for me. Some of the events on my slice are in your past and some are in your future.
Exactly. And here's the key. Neither slice is wrong. They are just different valid perspectives, different angles to the same bulk of data.
This brings us to a massive philosophical implication. There's a phrase in the source material that just jumped out at me. It's written like an equation. Existence, observation.
Existence is perpendicular to observation, orthogonal to it.
Let's chew on that. What does that actually mean in plain English?
It directly addresses the fear of solipsism. You know, the idea that if everything is just my world tube, my perception, does that mean the rest of the universe vanishes when I'm not looking?
Right. Does the tree falling in the forest make a sound?
And the author says, no, the tree exists.
Thank God.
The model makes a critical distinction between the absolute universe, which you could call the hardware, and the world tube, which is your personal user interface. The absolute universe definitely exists. It's the underlying field where light waves, Maxwell's electromagnetic waves, actually travel. It's the x-axis in the abstract, stretching out to infinity.
So the star exists even if I don't look at it.
Correct. But, and this is the kicker, you can never, ever access that absolute universe directly.
Why not?
Because of twin dollars. That pseudo-photon lifespan, the radius of your observational semicircle. If an object exists at a position, sex $100, but your personal value is only 50.
I can't render it. It's just outside my draw distance, like in a video game.
It is off your map. It exists, but it is geometrically perpendicular to your observation. Its coordinates do not intersect your semicircle of now.
So there are things happening right now. Supernovas exploding, maybe entire alien civilizations rising and falling that are physically real, but they are geometrically impossible for me to observe because the information hasn't entered my tube yet.
Yes. And even for the things you do see, you aren't seeing them as they are absolutely. You are only seeing their reconstruction based on the signal delay. You are seeing the echo, not the shout.
So we are all trapped in our own little bubbles of history.
We are all walking around inside our own personal lag bubble.
This brings me back to the Blender scripts, because we've been talking about this being a user interface theory. The author didn't just write down equations, they actually wrote code to prove the concept.
This is my favorite part of the whole thing, honestly. The Observation Reconstruction Model Complete document includes Python code written for Blender. And Blender, for anyone who doesn't know, is a free open-source 3D animation program.
So they built the tube in 3D.
They built a camera that sees according to the rules of the tube. Usually, a virtual camera in 3D software works like a perfect pinhole camera. It draws straight lines from every object to the lens, creating an instantaneous image.
Right.
The author wrote a script that completely hijacks that process. It forces the camera to render the 3D scene based on the equation x to x dollars plus m2 equals r22.
They actually programmed the lag into the camera.
They programmed the observational delay. They created a virtual camera that has to scan the 3D scene. If an object is far away from the camera in the 3D world, the script forces the camera to wait to render it, effectively pulling its image from a memory buffer of previous frames.
Then what does it look like when you use it?
It creates the relativistic effects visually. If you move that custom camera quickly through the 3D scene in Blender, the objects in the scene appear to distort, to contract, to shift in time exactly as special relativity predicts.
So they proved it by simulation. They built the user interface.
They showed that if you treat relativity as a rendering shader, a post-processing effect, rather than a physical warping of the space-time grid, you get the exact same final image.
That is just.
Yeah.
It's profound.
Yeah.
It implies that the universe might literally be running on code, or at least the logic of our perception of the universe is compatible with the logic of a rendering engine.
It aligns very neatly with the simulation hypothesis, but in a very specific technical way. It isn't saying, we are all just characters in a giant video game. It's saying our perception adheres to the fundamental limits of information processing.
The weirdness of relativity is just you have high ping.
Exactly. The universe isn't weird. Your cosmic internet connection is just laggy. The m-axis is literally your ping axis.
So when I look at a galaxy a billion light years away, that's just massive ping.
That's a huge lag spike. You are looking deeply, deeply into the m-axis.
I want to circle back to the AI's role in this one last time, because the source really emphasizes that the human author had to force this new view on the AI. The AI resisted it.
And that resistance is key. It shows you just how deeply the standard model of physics is ingrained in our collective data. That AI has read every physics textbook, every scientific paper ever written. It knows with a high degree of confidence that Einstein is right.
It's biased by the scientific consensus.
Right. And for the human to come in and say, no, ignore all of that. Use the unit circle. Do not use time dilation as an explanation required a massive act of creative will.
It's prompt engineering as a new form of the scientific method.
It's a kind of counterfactual modeling. The author used the AI to rigorously explore a universe that doesn't exist in our textbooks. And the AI, once it was stripped of its bias, it acted as a perfect logical stabilizer. It checked the math. It would say, okay, if we assume these new rules, then logically, $X plus M22 must equal $2
It's the ultimate collaboration. The human provides the crazy what if, and the AI provides the rigorous then this must follow.
It really suggests that the next Einstein might not be a patent clerk in Bern. It might be a prompt engineer in their basement arguing with a language model.
That is both incredibly exciting and a little bit terrifying.
It's the democratization of theoretical physics. You don't need $1 billion grant and a particle accelerator. You just need an API key and a really open mind.
So, after all this, where does this leave us? We have a universe that is, in a way, simpler. No shrinking rulers, no magical time slowing, but our view of it is infinitely more complex. It's a personal, reconstructed mosaic.
I think it leaves us with a necessary sense of humility. We are observers. We are limited. We are not the omniscient mathematician looking down at the map.
We are just people in a moving car trying to catch rain in a tilted tube.
And finally realizing that the tilt is what makes the world look the way it does.
The source material ends with some explicit prohibitions.
Yeah.
It lays down some rules for the road.
Yes. 3 main ones. Number 1, do not call M time. Number 2, do not treat the tube as a solid physical object. And number 3, do not confuse the map with the territory.
It's like the 10 commandments of the M-axis.
And it's for a very good reason. If you break those rules, you slide right back into the old paradoxes and the old ways of thinking. You have to stay disciplined in the geometry.
Okay, I'm going to leave you, our listener, with a final thought to chew on. We just discussed that phrase, existence is perpendicular to observation.
Mm-hmm.
If that's true. If there's a whole, vast, absolute universe out there that we can't see because of our dollar limit, and if our current view is just a user interface, what is that real universe actually like?
That is the ultimate question, isn't it?
Is it just a simple, boring Newtonian clockwork universe underneath it all? Or is it something even wilder than what we see?
And is it possible that quantum mechanics, all the really strange stuff like entanglement, superposition, things being in 2 places at once, is just another artifact of the interface?
Oh, no. Don't do this to me right at the end.
You know, think about it for a second. If you have really high ping in an online video game, what do other players sometimes do? They teleport. They glitch from one spot to another without traversing the space in between.
You're saying quantum tunneling is just lag, the universe glitching out.
I'm not saying it is. But the observation world 2 model opens the door to asking that question in a serious way. Are we constantly confusing the inherent limits of our sensors with the fundamental nature of reality?
Maybe the universe makes perfect, simple sense. And maybe we are the glitch.
I think that's a very distinct and humbling possibility.
Well, on that existential bombshell, we are going to wrap up. I want to thank you for guiding us through this geometry. My M-axis is throbbing, but I think I finally see the semicircle now.
It was a pleasure. Just keep visualizing that horizon.
And thank you, the listener, for taking this journey with us. If you want to break your brain even further, check out the show notes for links to the ChatGPT to Gaussian ad transcripts. Try to build the tube in your own head.
Just remember the rules. Don't confuse the shadow for the object.
Check your rotation, watch your ping, and we'll see you on the next deep dive.